So if you are just clicking in and getting connected here, I am going to start with the introduction, and then we will turn it over to today's speaker. So welcome, everyone. My name is Tom Reed. I am the program director for the Energy and Manufacturing in Appalachia program. This is a program that is managed by several manufacturing extension partnership organizations and some other economic development groups that support this effort to help manufacturers be more energy efficient and to expand more work into energy supply chains. We have been around now for a couple of years, and we have several good resources. I want to point out there at the bottom of the screen that you see there, the wemakeithere.org/energy. I'll also put that in the chat so everyone can see that. There's a lot of good resources and information on the site, including energy reports like the geothermal report that you're going to learn more about today. But we have probably coming in on about 10 reports to date, and we probably have another 8 or so that are in the works. So, please join us. Please take a look at the information. There's a lot of good things there. We also have information about grants and programs that can help manufacturers who are looking to expand in energy and be more energy efficient, including we have a mini grant program you can see again on the website to receive up to $10,000 towards a project to help you accomplish those goals of the EMA that I mentioned earlier. So looking ahead, you're going to see we have a couple of events coming up. We have the fourth of our 4-part AI data centers reporting and webinar series, and this is our 4th and final one, or at least as of now, and it's going to focus on structural steel. Then we have a webinar talking about seizing growth and opportunity in the plastic supply chain on December 4th. And then finally on December 18th, we have a solar supply chain report and 2026 outlook. So that'll get us through the end of the calendar year, and we have a whole stack of reports and topics that we have planned for 2026. So just stay tuned if you want to see. You can see we have kind of on deck here, natural gas midstream, circular plastics, hydrogen, chemicals, and electric grid components, among some others. But today we're going to talk about geothermal. So we're going to reach down into the ground, learn more about the geothermal industry and how manufacturers can be involved in the components and the parts that come together with that. So with that, I'd like to welcome Kevin Sunday. He is the Director of Policy at the McNees Government Relations, which is part of the McNees, Wallace & Nerick law firm. He focuses often on energy and infrastructure. And so I think that this is going to be a great opportunity to learn more about geothermal, something that I think we've been using geothermal warmth in the world for many generations, but there's a lot of new opportunities out there, and there's great opportunities for local manufacturers. So welcome, Kevin.
Good morning. Thanks, Tom, and thanks everyone for joining us. Appreciate the opportunity to partner with the Energy and Manufacturing in Appalachia initiative and talk through this report on supply chain opportunities in the geothermal industry. I'm going to focus specifically on enhanced geothermal systems. There's many flavors of geothermal. The major growth is going on right now in what we'll call EGS. So I want to talk a little bit about the basics of geothermal, what the resource potential is, what is enhanced geothermal, what are some barriers and catalysts to deployment, what are some of the opportunities for manufacturers in the region, and then briefly identify some key developers and suppliers that you might see as you dig into this very exciting industry. So at the very basic level, when we say geothermal, we're just taking heat out of the earth, which we know way down in our core, we basically have this miniature sun, this giant nuclear reactor that produces a tremendous amount of heat that works its way up through the surface. And that hot rock, when it hits water, creates steam. And we can use that steam for industrial processes. We can use it for heating and cooling. You can use it to power electricity generation. There's even a way to do thermal energy storage. Right now, the best states that you see the most geothermal projects are in California, Nevada, Idaho, and Hawaii. They sit on fault lines where there's just a lot of hot rock near the surface. But we're starting to see, sort of coming a little bit more eastward into Texas, New Mexico, Utah, and Colorado, more use of enhanced geothermal systems. Now, overall geothermal in terms of the power portfolio is less than 1% of electricity generation. So in the US pie, it's a small slice, but as a country, we are, depending on the year, tied with Indonesia for producing the most raw kilowatt hours of geothermal power every year. In terms of what country gets its highest share of geothermal in its power portfolio, that's Kenya. I would note that on the state side, California and Nevada get about 10% of their electricity from geothermal. That's going to be the conventional hydrothermal space, which we'll talk the difference in a little bit. There is a tremendous amount of technical potential for geothermal. If you think just about the raw amount of energy that's in the earth core, it greatly dwarfs how much energy there could be with fossil fuels and even the nuclear supply chain. And what's also compelling about geothermal from a surface footprint is because all the combustion is essentially taking place under the subsurface, and you just need a relatively small facility to run the piping and run the heat through compressors and turn it into power, use it on site. You don't have a lot of surface footprint. So you compare it to the chart on the right. This is from a geothermal report in Texas. You can see in terms of land use, it's a very energy dense resource. Yeah, this chart shows a little bit what I was just talking about. Where is the potential? There's a lot in the Mountain West states and the traditional oil and gas basins. But as you might be interested to see for folks in the Appalachian Basin, there's a pretty good band in the traditional conventional oil fields of Northwest PA, and a pretty strong potential band running up the western ridge of the Appalachians from West Virginia into Southwest Pennsylvania. This was part of a desktop analysis from the National Renewable Energy Lab about 10 years ago. I can say that if you take a look at some more recent analyses, including the Texas report that I pulled from, when they look at some actual drilling logs, there's a lot more resource potential out there. And folks like the Project Interspace Foundation, which I'll talk a little bit more later, have partnered with Google on a geomap where you can get some more fine-tuned data on what the resource potential is in your state or country. It is a global database that you can pull information out of. So we have all this heat under the surface. What do we do with it and how do we harness it? There's ground source heat pumps, which I mentioned. This is for building HVAC. There's conventional hydrothermal, which is what we've seen in California, Nevada, and Hawaii, where if you're familiar with the oil and gas industry, you hear terms like conventional and unconventional. Conventional just means the resource is there in a large reservoir under pressure. You don't need to do much with it. You just need to get a pipe into it and the pressure relieves. And just like we would see in the old days of the oil geysers, the oil shooting up, the hot water just comes to the surface under pressure as steam, and you put essentially a turbine or heat exchanger on top of it, and it spins it and gets the power out of it. What enhanced geothermal systems is sending water down where it's not naturally occurring onto hot rock, so very similar to hydraulic fracturing. And the advances from hydraulic fracturing over the last 20 years, we're starting to see a lot of tech transfer into the geothermal space. And the emerging states that I mentioned, Texas, Colorado, Utah, New Mexico, where there's a lot of been a lot of horizontal drilling activity. We've gotten a lot better at seeing what's beneath the surface. And I guess I should say, when we say fiber optics, it's actually it's actually a kind of acoustics, which is what's really interesting. When you're trying to see beneath the surface, really what they do is they're running sound waves to see what the contact is and what the response is. So we've gotten a lot better at harnessing hard to get oil and gas resources. And now we are able to essentially duplicate that process with geothermal wells to take water from the surface down to where there's hot rock, but not water, and run the water across the hot rock to produce steam to bring it back up for power generation or direct industrial use. The Department of Energy thinks about of all the geology out there that you could do geothermal with, only 2% of it is that conventional hydrothermal or where there's water down there. And so EGS is taking the water down there. And one question we get a lot is it the same frac fluid as you see in oil and gas? And the answer is they're similar, but not quite. There's two key differences. One is just what you're doing with hydraulic fracturing for oil and gas versus geothermal. And hydraulic fracturing, the oil and gas is contained in very small pockets in the rock, and you really need to break the rock apart and use a lot of proppants and polymers to really bust up the rock. With a geothermal well, you're basically, the term is more shearing. You're just trying to run a channel to get good contact between the water and the rock. So you don't need a lot of the extra additives that you see in an oil and gas frac fluid. The other difference is because the geothermal rock in some cases is 300 or 400 degrees, those temperatures are going to basically unwind some of the organic additives that you see in a oil and gas frac fluid. So it is a much simpler, more water-based compound than frac fluid, but a lot of the other technology is very similar to what you see on a horizontal rig. And the Department of Energy is trying to, both in this and previous administrations, push down the cost curve on geothermal because there is a significant potential across the United States to deploy enhanced geothermal systems. So to date, we have about in terms of installed capacity, 3.7 gigawatts of geothermal in the US, again, mostly the conventional. The EGS is where we're seeing a lot of growth into these new markets. Estimates are it could grow 5 to 7% a year and globally get to a $4 to $11 billion market by the end of the decade. We're seeing a lot of demand pull by tech companies who want to see 24/7 power for their data centers. We're seeing a lot of interest by the Federal Department of Energy as well as Department of Defense, where they've got facilities and installations across the US and across the world, frankly, that need reliable power. They can't go offline. If you're landing your aircraft, the lights always need to be on to show them where the runway is. If you got the data farms to power the next generation of technology for the warfighter, that always has to be up to keep them live to identify their targets and strike with precision. So those are the big demand pulls we're seeing right now. This map is a little bit different from what I showed before. It's basically how deep do you have to go to get suitable temperatures for enhanced geothermal, which in most cases you need to be above 200 degrees centigrade, though there are ways to get power generation from a less than boiling point. In our region, you've got to get probably below Marcellus depths to make it work. And that's where a lot of the cost of geothermal comes together. And technically, it's you're going to see a lot of the challenges in the upfront drilling costs, which is where DOE's focus is on bending that cost curve down. So I talked a little bit about the potential. Let's talk now about the challenges. Drilling cost is one. Characterization of resources is another. Subsurface is hard. Geology is not straight stratification everywhere. It could be very hot in one part of the county and just a few hundred feet over, not hot enough. Geothermal traditionally, until the last few years, has just not gotten the attention in terms of direct R&D and tax incentives compared to others. There's been some cloudiness in terms of regulatory uncertainty in the states. States are starting to figure this out, but some of the challenges, particularly out west on water rights, mineral rights, who owns the heat of the rock. In Pennsylvania, we believe it's pretty clear it's part of the surface estate. Uh, Grid integration, as everybody knows right now, it's tough to bring new power projects online, given a lot of constraints on equipment and interconnection process. Finance, the report on the right that this table is from just shows over, a few year period what the strike price was for power purchase agreements. And basically, as you go through time, wind picked the lowest hanging fruit, and then costs went up over time, and then economies of scale kicked in, and they got better at figuring out where to build the wind. Solar has been a cleaner story in terms of utility scale getting cheaper and cheaper as the price of the modules come down. But geothermal just has not seen a similar amount of private sector financing, and so its cost curve has been a little stickier in terms of coming down. But it is in a positive trend. About a year and a half ago, Department of Energy was doing these various liftoff reports when they talked about investment strategies to bring costs down. And I won't walk through this in tremendous detail, but essentially they said, look, we've gotten about a 50% reduction in just a few years by investing in some pilot projects and watching the oil and gas industry come out of a lot of drilling activity in the 2010s and getting their costs down. If we want to get down to a very competitive $45 per megawatt hour target, you got basically three main cost drivers: exploration, which is figuring out where to put your wells and doing data collection analysis; actually drilling your wells, casing and cementing them, and then running your power plant. And basically, DOE strategy then and continues to be, the more you do these things, the more you learn by doing, the more the costs are going to come down, and it's going to really be a flywheel effect to take off. As I think many folks in the energy and manufacturing community are aware, there's been a lot of change very quickly in terms of DOE's financing strategy and what the federal government is putting their weight behind. Geothermal has been treated pretty well. The Secretary of Energy, Chris Wright, previously ran Liberty Resources based in Colorado and was an early investor in one of the leading geothermal companies, Fervo. And it was reported as they went through the One Big Beautiful Bill in the budget reconciliation process that Chris Wright leaned in heavily to preserve a lot of the tax and loan provisions for geothermal from the Inflation Reduction Act. So it's kept both its PTC and its ITC, and we're continuing to see a lot of interest, as I mentioned before, from federal research labs and military installations and the data center market. We also see in the states starting to add geothermal into their energy efficiency and renewable portfolio standards. There's some discussion of that here in Pennsylvania, and getting their permitting a little bit more clear. We're also starting to see a lot of interest in some industrial facilities trying to, as they, eyeball these increasing power prices and look to alternatives. Geothermal is something some are looking at. I mentioned before that you can do some other things with geothermal, and this thermometer from another DOE report really lays that out. So if you go from top to bottom, obviously the most, in many cases, the most valuable use is power generation. We're scarce for power right now. We need a lot of it. The challenge is you need very high temperatures to do that. But that doesn't mean to say lower temperature rock doesn't have use. This is where we see in the medium term a lot of opportunity for Pennsylvania in industries like cement and aggregates, pulp and paper process, lumber, really the commodity ag spaces from food process. So think about drying seed, drying grain, heating your vegetables, doing dairy pasteurization, keeping your fish farms warm enough to not freeze, building heating and cooling as well. Those are ways to get at geothermal at lower temperatures. There's also some really emerging technology cases, as I hinted at earlier. One is if you want to get some of the lithium and rare earths out of the ground, you can use basically a geothermal well to do that. You can do thermal storage, where you are, for what they call a geo exchange network, doing a number of shallow wells for building heating and cooling. You basically send your hot air from the summer down and in the winter draw it back up. Or you can do subsurface, basically almost like a pump storage hydro system where you run water down through the geothermal well, lock it in during the late afternoon when you have excess solar, and then bring it back up at night as a basically a naturally occurring battery. You can use it for hydrogen storage, and this is also a potential use case when you have abandoned and orphan wells or oil and gas wells that are running out of their productive life. If there's heat down there, you have the potential to do something with it. So focus for this initiative has been supply chain. As you might guess from the presentation, there's a lot of tech transfer, a lot of market crossover from oil and gas field services equipment. So your pipes, your pumping equipment, your compressors, your subsurface fiber optics, your precision controls all look very similar. Well, it's the same type of pipe. Generally, there's a couple differences. The size is a little bit bigger depending on how much water is flowing. And if you're going really deep, it may need to be a more heat resistant specialized pipe than what you might see in traditional oil and gas space. The heat exchangers, these are basically ways to bring the heat up and spin a turbine for power generation. Orkin-Rankine cycle is what ORC stands for. And we also, if you're in the power generation space, everything we know we need there: turbines, switch gears, transformers, poles and wires, basically to get the power from the wellhead out to the transmission system. As you dig into geothermal, you'll see a few of these names over and over again. Fervo is at the front of the pack in terms of EGS. They are partnering with Department of Energy at the Utah Forge project in Western Utah. This is a deep multi-well enhanced geothermal system. That is where we're seeing a lot of the cost reductions come and a lot of interest. As this proves itself out, Fervo has partnered with some data center developers in Nevada and other states to power theirs. Sage is doing both enhanced geothermal and subsurface storage. They just partnered with Schlumberger and Ormat on some next generation projects. Ormat's traditionally in the conventional space, but has been around with a lot of geothermal experience. Gradient's focus is on converting end of life or dual use oil and gas wells to geothermal. Ever is focused mostly in Canada in a closed loop system, which I didn't talk as much about, but essentially you keep the water within a multi pipe system underneath the ground, almost like a radiator, and just draw the heat off that. You get a lot less water loss, but it's much more costly upfront because you're drilling so much more pipe. And then the big oil field service companies, Baker Hughes, Halliburton, and Schlumberger, all have geothermal low carbon portfolios where they're working alongside things like hydrogen and carbon capture, basically trying to get low or zero carbon services with subsurface activity. There's others out there, but if you dig into geothermal, these are the names that you're going to see the most. And if you want to learn more, here and in the report is a list of some other associations, groups, and resources to dig into that are either providing financing, a lot of information, or even in the last two, Groundwater Protection Council and IOGCC, convening and discussing with state regulators how they permit these resources. So I will stop there and happy to take any questions the group has.
Okay, thank you, Kevin. And I would encourage anybody, if you have more questions, to submit those. But we do have two. Again, thank you for the excellent presentation. It says, can these shale wells be used or reused for geothermal? And do you need to wait until they are done producing gas?
So I would say the answer is yes. On the first part, they can. There is some temperature reads on old well logs, basically down in Utica, just sub-Marcellus, that the temperature might be suitable for some of the industrial use, or maybe with some tech improvements out west in the next few years, power generation. It depends a lot on continued integrity of the pipe, and if the pipe that they ran for gas is big enough to bring up enough water under pressure to run the turbine. On the do you need to wait? I think Gradient has done both in Colorado, running gas through hot rock and getting, they basically bring up and the gas goes one way and the hot water goes the other. They've also done basically at end of life converting a producing gas well to a geothermal well. So there is potential. And as I mentioned, if you have the drilling already done, that takes a lot of the costs out of the equation.
Okay, great. And then this ties into the cost. It says you mentioned the high development costs compared to other energy sources. If you know, how does geothermal compare to traditional energy sources in operating costs, or say the first 10 years of each resource?
It is much more on the CapEx than OpEx side. I'd have to dig in through where it stacks up. Certainly not come down as much as solar has. We can get more details on the cost side of things.
Okay, but as you mentioned, it's the upfront cost is one of the barriers right now versus the operating side.
Right.
Okay. A couple more questions coming in. Says, are there legal ownership issues related to the resource in surface or subsurface estate owners?
It's a lot cleaner this side of the Mississippi where we don't have, prior appropriation water rights that the Colorado and other states have to deal with. I should have mentioned Project Interspace in Penn State. I worked with them on a report on Pennsylvania's geothermal potential, and a few folks, including one of the attorneys here at our firm and a law professor at Villanova, looked into that subsurface question, and their general conclusion was that the subsurface rights, unless they've been explicitly severed, the right to heat is part of the water, part of the surface estate.
Okay.
And I'll put that Penn State report in the chat too, if anyone wants to dig into it.
Good, thank you, and we'll share that email too. So thank you. One more question here says drilling in the correct location seems really important. Are most companies using AI to find the right spots to drill?
That's a good question. I would presume that AI helped build the GeoMap resource that Google and Project Interspace put together. What AI could, and I believe in some cases has done, is if you have a big volume of data of old drill logs to go through and compare if, the engineer in 1981, when he took a temperature reading in Clinton County, wrote down 300 degrees. Does that make sense based on what else is out there? Or was that he just filled it out? Because what did it matter what the temperature was, 40 years ago, before we really were doing geothermal anywhere in oil and gas basins?
All right. Okay. Well, I think you covered everything. So definitely appreciate your time, your expertise. We will share the slides with everybody afterwards, and as well as a copy of the recording if you want to share it internally with your team. So Kevin, thank you for coming on today. Appreciate your information in the report. Again, if you got the link, everybody, you may download the report or we'll share that with you again. But definitely thank you everybody for joining us. And on behalf of Tom and myself, Kevin, thank you for the presentation.
Thanks, everyone.
Thank you.